Welcome to this global launch of the 2025 edition of the National Ecological Footprint and Biocapacity Accounts. This edition details the ecological footprint of production, of trade, and consumption from all countries from 1961 to 2024, and the biocapacity within the boundaries of these countries. This edition also provides a global sum of the ecological footprint of all of humanity and the biocapacity of the entire planet Earth. This webinar will introduce you to this data set and how we account for the composite metrics of ecological footprint and biocapacity. And we define their components as well. We will present to you global results that we've generated and a sample of national results and instructions on how you can access the data for your own analyses. We will also profile some interesting findings with respect to trade flows and their significance from an ecological footprint perspective. We will reflect on the last 25 years of trends and explore scenarios of the next 25 years as we think about potential pathways to end footprint overshoot by 2050. Finally, we will speak to some of the research and development underway by our team to enhance the accounts and to work with partners around the world through the International Ecological Footprint Learning Lab. For everyone joining us live, we will conclude the webinar by engaging with your questions and comments. Many of you have already submitted comments through the registration, and we also welcome you to log additional questions to the Q&A feature on this Zoom platform. Or in the chat as well. That feature is available for you as well. We will also sort of challenge you to reflect on some questions, sort of poll results as we go through. And potentially you'll want to log your responses in on the chat if you'd like to share that information. And at this point, actually, we'll welcome you to paste into the chat where you're connecting to us from. We are so fortunate to have so many people from around the world, including many in time zones very different than our own time zone, the two time zones that we are in right now as a team. In this webinar, you will hear from 6 out of the 8 co-authors of this data set. Our team is based at 2 sites, at York University in Toronto, Canada, and at the University of Iceland in Reykjavik, Iceland. With me at York University is Kiona Lo, who led the production team generating this data set, along with Neha, Joanna Silva, and Peri Dworatzek, who is also the coordinator of partnerships with the International Ecological Footprint Learning Lab. You will also hear from Johanna van Berkum, based at the University of Iceland, which is also the affiliation of our co-authors Matt Dyke and Raquel Byrings-Hallosdorthers. We co-produced this data set while also working on other projects related to ecological footprint or biocapacity, often at different spatial scales or levels of aggregation. And those other projects use data such as these national accounts. And for that reason, even if you are interested in the application of ecological footprint and biocapacity at other spatial scales and other levels of aggregation, this data set that we'll present to you today is also an anchor data set for those other applications as well. So with that, I'm pleased to pass the podium over to Kiona Lo to introduce the data set we call the National Ecological Footprint and Biocapacity Accounts.
We are very excited to share with you this new 2025 edition of the accounts. So for this 2025 edition, we produced the National Ecological Footprint and Biocapacity Accounts for 244 countries and territories that currently exist or have existed from the timeline of 1961 to 2024, with 2024 being that additional year compared to the last editions. And for 191 of these countries in the world, we have a reliable timeline of data, and we provide them on our websites for you to access. To generate these accounts, we use data from a variety of reputable and official sources for emissions, for production, and trade data. A lot of our data sets come from the United Nations, particularly the United Nations FAO, which is the Food and Agriculture Organizations of the United Nations. And for each edition, we use the most updated data from the data sources to generate a new editions of our accounts. And in this 2025 edition, there have been minimal changes in the world total, but there are some country-specific difference. For example, for New Zealand, there have been some differences because of updates in its area data. And to just showcase to you the amount of details we have in our database, we have here a table that shows the number of sectors, products, commodity, and species we have our data on. I think the most impressive one is our fish data, which we source from the United Nations Fish Stat. We have around 2,000 species of fish capture data when we combine both marine and inland capture together. So using this data allow us to generate the footprint for the national accounts, but they also allow us to analyze trends in productions and also trade, which have been on the news a lot lately. So with this, I want to ask our audience the first trivia questions we have. So among the following 4 food items, which one has the highest globally traded mass in year 2024? So the answer for this question is actually maize. So in 2024, there were around 209 million tons of maize traded globally, which accounts to around 92.6 million of global footprint hectares. So from this next graph, we can see the global trade of these 4 items in terms of mass over the years. And we see that there have been much more crops traded compared to livestock in terms of their mass. And maize has always been traded the most compared to the rest of the food items. So this kind of detailed data is the ones that we use, and that goes directly into how we quantify the ecological footprint for all the countries. And to explain how we go from food items to footprint, I'll now pass it on to Joanna, who will walk us through the conceptual framework of ecological footprint.
So let's start by discussing the conceptual framework of the ecological footprint and biocapacity. When you think about all the goods and services we consume in our lives, whether it be food, the clothes, the products we buy, the places we live, work, and play, and all of the carbon emissions that come from producing and consuming these goods and services, all of the production and consumption of renewable resources fits into 6 different components of ecological footprint, as it's the area needed to sustain humanity. First are the fishing grounds. Fishing grounds are the areas of marine and inland waters needed for human consumption of fish and other aquatic species. Next is built-up land, which is the area of land occupied by human-built infrastructure, such as houses, other buildings, roads, and urban green spaces. Next is cropland, which refers to the area of land needed to grow crops consumed by humans and foods or fibers and crops fed to animals and fish that are consumed by humans. Grazing land is the area of land needed to feed livestock consumed by humans beyond the feed supplied by the cropland component. Forest products is the area of land needed for forest harvest to derive pulp and timber products. And finally, the forest carbon uptake component is the area of forest needed to sequester anthropogenic carbon emissions beyond that are sequestered by the world's oceans. Now let's discuss the other side of this metric, biocapacity. Biocapacity is the area available to sustain the renewable resources to meet the demands of humanity. Biocapacity is made up of comparable components that were listed with the ecological footprint. However, the only difference being that the forested land has a dual purpose of measuring both the area that can supply products derived from pulp and timber, as well as the area that can sequester carbon emissions. So now that we've defined both concepts of ecological footprint and biocapacity, how are they quantified? It's quantified using a metric called global hectares. Global hectares are a single spatial unit that is a hectare of land that provides a world average amount of biological regeneration each year. Using a single unit allows for comparability. There's a comparability between what we demand of the environment and what the lands and waters can supply. And global hectares also allows for comparisons between time and space. Another great thing about this unit and framework is that it can be applied at other scales. For example, we could present the accounts at a national level, and yet we can also derive a global level by summing up together all countries. The ecological footprint and biocapacity can also be applied at the community, regional, and provincial scales, as well as other scales. Now that we've looked at the framework, let's look at the global results. So here are the results for the 2025 edition for the ecological footprint and biocapacity data for the world. summing together all the countries from 1961 to 2024. Since we use global hectares, we can divide ecological footprint by biocapacity to understand if humanity has produced more than what the Earth's lands and waters can regenerate within a year. If the results go above 1, then we have used more than what is available for the year. Similar to the results of the last editions, you can see that there was a decrease in the trend for the year 2020 due to the COVID-19 pandemic. 2 editions ago, we've innovated our methods to be able to extend the data up to our current year so far. This edition can show up to 2024. As you can see, there's quite a jump after the pandemic, more of a rebound than we initially expected. However, since then, we've seen that the rebound has begun to level off a bit, with 2024 being another year of record year of being the highest level of ecological footprint to date. However, the amount we're seeing from a year-over-year growth is more muted or less pronounced versus historically. As you can see from the red line on the graph, humanity has been using more resources than what the Earth can regenerate within a year. This is called global overshoot. Humanity has been in an overshoot for over half a century, since the 1970s. In addition to having global data from 1961 to the present data, we also produce data for all countries in the world on a national and trade basis. Now I'll pass it off to Neha to talk more about the national and trade basis.
Within the framework of ecological footprint and biocapacity accounting, we measure the ecological footprint of production that occurs within the jurisdiction. We also measure ecological footprint embedded in imports and also the ecological footprint embedded in export. Then with the information about the ecological footprint associated with all the production that took place in a jurisdiction in the year and also how much was embodied within the imports into that jurisdiction and how much of that jurisdiction production and import was used to support export, we then derive the ecological footprint measured on a consumption basis for each of those countries and territories over that timeline by using simple arithmetic formula as displayed in the slide. So to calculate the ecological footprint of consumption, we sum the ecological footprint of production and import and then deduce it with the ecological footprint of export. While doing so, we convert physical land area measured in hectares into global hectares, as mentioned earlier, which is also the unit of account that allows for comparability across the planet and over time. We also measure of global hectares on a per capita basis, which is useful for the comparison across those countries and across over time on an average per person basis as well. So within this sort of accounting system and within this framework, we've got a lot of interesting information for all of those countries and each of those years with each of these components identified. So in the following slide, we will present you an example of what some of the data look like for Canada in the year 2024. So this is a bar graph that identifies from the left to the right the area of Canada that yields biocapacity in terms of those components that was identified earlier while defining ecological footprint and biocapacity. So you can see that the biocapacity within Canada on global hectare basis is less than the total number of hectares. For instance, the biocapacity measured in global hectares of fishing ground is lesser than the total number of hectares for Canada, while on the other hand, when it comes to cropland, you will see that there are more global hectares of biocapacity with respect to cropland in Canada than there are of hectares. And that's because the cropland in Canada tends to have higher yield per hectare compared to the global average yield of cropland. In the Canadian context, this graph shows that somewhere roughly 80% of the country's biocapacity is generating flow of ecosystem goods and services. So these flows are quantified in the ecological footprint of all production that took place in Canada in the year 2024. So looking at the ecological footprint of production is quite sizable compared to the ecological footprint of import and export. And also to note here, the ecological footprint embodied with all the exports from Canada to the rest of the world is roughly twice as much as the ecological footprint embodied within import. So as we tend to export materially intensive products like timber, it will be interesting to see how this balance will shift in the future edition. Then with the balance of all that yields the ecological footprint of consumption measured in terms of the global hectares. So this is the total in terms of the hundreds of millions of global hectares related to the ecological footprint of consumption in Canada. And of course, this is all comparable to any other country in the same year or any other year. So if you are interested in having graphs like this for a specific country, then we can share this by email request. So for further engaging with the data and interacting with it, there are a couple of ways you can do this. So one is through the Ecological Footprint Initiative website on the Data tab. Anyone can download this data workbook that includes national and world ecological footprint and biocapacity data in total and for the components. This is also accessible through our web URL on the screen or by using the QR code. And also to add that this data is live and has been posted already along with the release note for the edition. Now I will pass it over to Peri, who will take us through a deeper dive into some interesting trade statistic.
So let's turn to another footprint trivia question. This one's asking, which of these countries below had the largest ecological footprint of net imports in 2023? And so the hint given is that net imports equals ecological footprint of imports minus ecological footprint of exports, with 4 different responses. So A, Singapore, B, Mexico, C, Italy, and then D, the United Kingdom. The answer for this question is Italy. For the year 2023, Italy had roughly 228 million global hectares of ecological footprint imports, and then 110 million of global hectares of ecological footprint of exports. So you can see it's roughly double, they have roughly double the ecological footprint of imports over ecological footprint of exports. So if we were to plot all the countries in the world on a bar chart using this idea of a trade balance, this is what it would look like. So all of these blue bars are different countries. And so countries with ecological footprint of imports larger than ecological footprint of exports are on the left, whereas countries with ecological footprint of exports larger than ecological footprint of imports are on the right for this 1 year in 2023. Of course, it can shift depending on the year. And so it's hard to see right now, but with this orange line that's going to come up, this shows where it sort of switches, where countries change from having imports larger than exports to exports larger than imports. So as you can see, there are far more countries who have ecological footprint of imports larger than ecological footprint of exports. So if we were to do some country callouts, we already know that Italy has the largest number of imports, has a larger amount of imports than exports, so it has the largest net trade balance. And then you can see there on the graph, the United Kingdom, Mexico, and then Singapore. And then on the other end, we have Brazil, who has the largest amount of ecological footprint of exports, larger than the imports. And then a country, for instance, like Chad is much closer to the orange line, showing a balance of around negative 300,000. So this is one way to examine trade data in the national accounts, is to look at this global trade balance for each country, but there's also many other ways to do that as well. So I'll turn it over to Kiona to examine trade dependencies.
So yeah, besides looking at trade using trade balance, we can also look at trade and also the relationship to footprint through trade dependency. So the first question we wanted to ask was, how much of the world's production is actually consumed by trade, which means that they're not consumed domestically from where they were produced. So to do this, what we have done was we took the world's ecological footprint of export or import for each year, whichever one is larger to represent trade, and we divided by the world's total ecological footprint of production. From this, we get the percentage of production that is consumed through trade. So just a side note here, for the world's, the footprint of production is equal to the world's footprint of consumption, because right now we're not trading with any other planet at the moment. So from this graph, we can see that from the 1960s, around 10 to 15% of our productions was consumed through trade. And over time, this percentage has increased steadily, and now it has nearly doubled to just under 30%. So this means that much more of what we produce, nearly 1/3 of the world's total production, is not consumed domestically, but rather through trade, consumed in another country. And another thing that I think is really interesting that I want to point out is that you can see there have been drops in the percentage which means that there have been more domestic consumption, less trade following global financial crises, like I have pointed out in 1998, 2009. But the decline associated with COVID is a bit delayed. It happened in near 2022 rather than in 2020 and 2021. So I think this is just something very interesting to point out. So in addition to looking at trade dependency on the world basis, we also want to look at it by country to see how dependent countries are on trade for their footprint of consumption and which one of them stands out. So here what we have done is that we added the ecological footprint of import and export for each country together and divided by their footprint of consumption in the year of 2024. So the results here is the ratio of the footprint of trade relative to their footprint of consumption. So for example, for Brunei here on the very left, so with the ratio of around 12, it means that for every global hectare of consumption by Brunei, there are almost 12 global hectares of production that are traded in the world, either between Brunei and other countries, for both import and export added together. And the bars being orange, it means that Brunei has more exports compared to an import, which means that it is a net exporter, where the rest of the blue bars indicate net importers. So they import more compared to the export. So from this graph, there are a few things that I want to highlight. So first of all, you can see that although the bars are kind of short, but you can see that there are more blue bars compared to orange bars. So this indicates that more countries are actually net importers in terms of their footprint of consumption. Actually, around 3/4 of all the countries rely more on imports compared to export relative to their IEFLL consumption. Now, with fewer countries that are net exporters, so only 1/4, but we can see that they have a higher ratio of trade to their footprint of consumption, such as Brunei and Uruguay on the very left. And this is because their economy focuses heavily on exports, particularly on products that have a high footprint. Like for Brunei, they export a lot of fossil fuel products like refined petroleum gas, and also because they have a small population and a relatively more modest footprint of consumption. And on the other side of the chart, on the right side, these countries with the lowest ratios are the ones that are less engaged in international trade. So here we see the Democratic Republic of Congo, South Sudan, and North Korea. And lastly, the red one, which we'll show in a second, it represents the median ratio of trade to the ecological footprint of consumption for all these countries. It is at 0.64. So this means that for the typical country, for every global hectare of IEF consumption, there's a bit more than half of the global hectare of production that is traded in the world. So this is what we want to show you, how we can use footprint to analyze trade patterns, trade balances, and trade dependence of the countries and even for the world. And now I'm going to pass it back to Eric, and we're going to look at footprint per capita.
And so I'll start this off with another question to pique your interest. Which of these countries had a greater reduction in ecological footprint of national consumption from 1999 to 2024? So that's a 25-year period, the 25-year period leading up to the final year release of our accounts. A is Uruguay, B, Netherlands, C, Venezuela, D, Japan, or E, Moldova. Here's what we found. Uruguay has, among these countries, a greater reduction in ecological footprint of national consumption over that 25-year period, a decline of 72%, which is quite significant, quite substantial. Compared to these other countries, they all also had declines in the ecological footprint of national consumption over that 25-year period, but less so than Uruguay. Netherlands in second place, etc., with this list in decreasing order of the declines. Now that's the reduction in total ecological footprint of national consumption over that 25-year period. With a twist on this, which of these countries had a growth in average per capita ecological footprint of national consumption over that 25-year period from 1999 to 2024? Moldova. So indeed, for the Republic of Moldova, there was an increase of 14% on a per capita basis of average ecological footprint of national consumption. The others all had declines on a per capita basis. Now, these questions that we just asked are sort of a segue or introduction or to emphasize the distinction between changes on a per capita average basis and changes in an aggregate basis for the country. Obviously, the ecological footprint of national consumption is a product of the average on a per person basis and the number of consumers over that period. And so reflecting on this 25-year period, it's really interesting to profile the variability amongst countries, but also clustering as well of the results of changes in ecological footprint of national consumption measured on an average per capita basis and changes on a total basis of the country. So here's a plot of the change or the growth in ecological footprint of national consumption from 1999 to 2024, that same 25-year period. And so on the x-axis, we've got the aggregate global hectares. And on the y-axis, we've got per capita global hectares. These are all the countries that we generated accounts for that existed over this time period. Some of the accounts, the countries that we generate accounts for no longer listed, existed over this time period. You can see there's a lot of clustering closer to the origin with a few very far away. Curiously enough, it almost looks like an image of a footprint with the heel at the origin. Entirely coincidental, I guess. But what I'd like to do now is vary up this graph a bit with a bubble plot with the size of the bubble being proportional to the global hectares of national consumption. So with that, you could see that even though there were some dots far away from the origin, those were somewhat insignificant from an aggregate global footprint perspective because the values were relatively quite small compared to those closer to the origin. So let's zoom in further. So this is a zoom in of just within that realm of growth rates in the realm of 200% or negative 200% over that time period, both on an average per capita basis on the y-axis or the total aggregate global hectares on the x-axis there. So a couple of things of interest of note here. So one is that you can see there are countries in all four quadrants. And so we can just do a quick tour of these quadrants to sort of emphasize what it is that we're looking at here. So in this quadrant here, this is profiling countries that have had a growth in the aggregate ecological footprint of national consumption over that previous 25-year period, and also a growth in the average per capita amounts as well. Largest bubble here is representing China. Second largest is India. Those countries and many others in this quadrant have experienced an increase in ecological footprint of national consumption in total and also on an average per capita basis as well. This other quadrant is where we find countries that have had a growth in the aggregate national ecological footprint of consumption, but a degrowth measured on a per capita basis. And so this is where we have countries such as Canada and Brazil, for example. On an average per capita basis, the ecological footprint of consumption of Canadians in 2024 was less than in 1999, but there were more consumers in Canada over that period, and so the aggregate global hectares and national consumption was larger over that period. In this other quadrant, we have countries that over this 25-year period have experienced a degrowth in aggregate national ecological footprint of consumption and a degrowth on the per capita basis as well. And so this is where we see some of those countries profiled in the preceding question that we asked, including, for example, Uruguay, as this dot represented here, and the Netherlands, as this dot over there. Netherlands' total ecological footprint of national consumption is greater than that of Uruguay, and so that's why it's a larger dot as compared to that. You can see, though, very impressive reductions over that time period, both on an average per person basis and also on an aggregate basis as well. And so many other countries are in this quadrant as well, including, for example, Germany, which has a very large bubble there as well, and so on. There aren't too many countries in this quadrant of a degrowth in aggregate, but a growth in per capita. But certainly there is that one of the question I just asked before, Moldova, also Ukraine as well. So reflecting all of this, it's important then to be mindful that when we're looking at trends in ecological footprint over time on a global basis, there are these various factors at play. And so the story for each country is going to be a story about the relative significance of changes on a average per capita basis and changes in an aggregate basis, reflecting that composition. And so it's within that sort of framework that I'd like to offer just a few reflecting comments, thinking about the next 25 years. So if we return back to this plot of ecological footprint on a world total basis from 1961 to 2024, the latest year of data available here, let's think about the next 25 years. So the next 25 years, more or less, will bring us up to the year 2050. 2050 is an anchor year for a number of things, including the world's commitment, more or less, from most countries, to reach net zero emissions. And what's really quite interesting from an ecological footprint and biocapacity perspective is that this accounting system relates very well to the measurement and understanding and pursuit and challenge of getting to net zero emissions, because essentially to get to net zero emissions requires that ecological footprint be within biocapacity as a necessary condition. That is that in the year, let's say 2050, if we as humanity on a total basis for all across the planet, if humanity were to achieve net zero emissions by 2050, that means that in that year of 2050, whatever amount of carbon emissions there might be from burning fossil fuels potentially in that year, it's no greater than what can be sequestered by the lands and waters of the planet in that year, as represented here by the forest carbon uptake component, which is net of the sequestration of carbon emissions by the world's oceans. And at the same time, there'd be still some, obviously, an impressionable amount of components of ecological footprint related to demand for forest products in that year, paper, pulp, timber, that sort of thing. Plus also, of course, areas of lands and indeed water to feed us. Also mindful of the amount of area that we'll occupy through infrastructure and settlements and so on. And so with this then, thinking about the future, it sort of raises the sort of question of the sort of pathway if we were to get from where we are today to get to there, what level of reductions would we need in ecological footprint as compared to biocapacity? And of course, this line is relatively easy to calculate. We can, in this case, figure out that if we can reduce that by about 2%, just over 2% a year, every year throughout this time period, then we can get towards ending overshoot of ecological footprint relative to biocapacity. Now, of course, big questions about the pursuit of that, how much is going to involve, for example, the shift from fossil fuels to biofuels, and the demands on cropland for having more biofuels, et cetera. What about afforestation? Where's the area going to be used for afforestation, et cetera? You can appreciate that a lot of these opportunities and trade-offs inherent with the pursuit of net zero emissions can be considered within the framework of ecological footprint and biocapacity accounting very well. So with all that, though, be mindful of the interplay between per capita changes in ecological footprint and also the total amount of consumers over that on the planet. Here's some work that we did profiling how we looked at the United Nations population scenarios from the World Population Prospects 2024. And there's a lot of scenarios that they offer, but we've profiled here what the future pathway of, on a world total basis, ecological footprint might be along the low, medium, and high population scenarios provided by the United Nations if we're applying with those scenarios to the 2024 level of per capita ecological footprint of consumption. So this is looking at just the effect of changes in population on a world basis and what they would generate in terms of total ecological footprint relative to biocapacity, assuming the same level of biocapacity, more or less constant from now until then. So with all of this, then you can appreciate that if we don't do something different, if we keep up our current rates on an average per capita basis, there will be a significant challenge of getting to the point of getting to net zero emissions. To get to net zero emissions, given those population scenarios, we can also figure out what rate of reduction do we need on a sustained annual basis over time to get us to that level. And so this is what it looks like for those three population scenarios. For the low population scenario, along with that scenario of the population across the planet, if we, on a planetary basis, reduce the average per capita ecological footprint of consumption, if we were to degrow that by 2.566% a year, every year, in a compounding way, that's what that's requiring to go in the low scenario to that point, versus, let's say, at the high scenario of 3.129% reduced on an annual sustained basis. Now, those percentages might seem small, or if you're really good with compounding math and so on, you might also appreciate that those are actually quite significant large numbers. Nevertheless, though, with those other examples that we profiled earlier, one other way to engage with this is to say, well, the whole world ought to be challenged, let's say in a low population scenario basis, the whole world would be challenged to achieve reductions equivalent to what's been achieved by the Netherlands over the last 25-year periods. So we can achieve globally for the next 25 years what was achieved over the prior 25 years in the Netherlands. Then with that low population scenario offered by the United Nations, we can get there. Going up to the high one, we don't even need to meet the total for Uruguay, but still, if we were to have the reductions that they've experienced over the last 25 years, certainly we can get there to within that as well. So some perspectives there, mindful of the interplay again between changes in ecological footprint on a per capita basis and also on a total basis as well. And so this kind of work on scenarios, exploring future possibilities and constraints and trade-offs in a net zero emissions context, etc. This all lends itself well to a lot of the work that we're doing right now through our international modeling collaborations with many people involved with our research partnership, which we call the International Ecological Footprint Learning Lab, where they're integrating this data set into computational simulation models and system dynamics modeling to understand what those futures could be and so on. And so with that, I'd like to pass the podium over to Peri to speak about the International Ecological Footprint Learning Lab.
So these national accounts that we've been sharing with you during this webinar are produced by researchers at York University and the University of Iceland, and that's made possible through the International Ecological Footprint Learning Lab. So this partnership, another way to say it is IEFLL, brings together organizations, researchers, and students from around the world to conduct research on advancing ecological footprint and biocapacity methodologies. Graduate students are trained in sustainability informatics to be able to produce these national accounts. Students also conduct research for their master's and their PhD theses in an array of topics that sort of fit into 4 research themes: improving the national accounts methodology, scaling ecological footprint and biocapacity to non-national levels, conducting ecological footprint assessments with people and communities to explore behavior change, and using ecological footprint metrics in future modeling scenarios, just as Eric showed before. So we have a lot of exciting research that's going on and many research opportunities to come as more and more students and researchers join the IEFLL partnership. If you are an organization or a researcher interested in collaborating on different research opportunities, sharing data, or any other resources, you can visit our website or send us an email. Both of these are listed on the last slide, and I can also put these into the chat. So now to showcase the brilliant work of one of our graduate students, I'll turn it over to Anne to talk about the research that she's doing with the IEFLL partnership.
The IEFLL partnership has given me a great chance to learn and collaborate, contribute to these accounts, and it's really been a pleasure to contribute to this real-world relevance. My work for this edition on the biocapacity component gave me a lot of insights on data sourcing. We currently use EU and UN data to describe how much of each land cover area exists in each country. You can go to the next slide. This works fine for most components, which are fairly homogeneous. But for the built-up areas, the lands covered by human infrastructure, it's less straightforward. Each built-up area is so unique. To illustrate this, I've added some images on the slide. There are 8 different cities around the world. We have Dubai, The Hague, Toronto, of course, Tokyo, Shanghai, Sao Paulo, many cities, Reykjavik also, of course. You can see that between the cities, they are very different in how much green they have, and also within the city, where that green is located, how the structure of the city is, it really has an impact on those biocapacities. So my research question for my research is how we can use satellite imagery to better assess the biocapacity of built-up areas. It has 2 main advantages. 1, it is globally available, and 2, you can see things that humans can't see. So we can go to the next slide. Optical satellites can use the electromagnetic spectrum to make images of the Earth's surface, and they can look beyond the visible spectrum, which is very useful. We can see from blue to red with our eyes, with our cones, but satellites can also see infrared or ultraviolet light. For vegetation specifically, we can even distinguish between different species, but in general, they have high reflectance in the green. That's why they are green to our eyes. That's due to the chlorophyll. The chlorophyll also absorbs a lot of red light for the photosynthesis, and we can use the infrared light to see growth patterns or, soil health, essentially. We can use these characteristics to see things that we usually can't see. So if we go to the next slide, I have an excerpt of the dataset that I'm using for the city of The Hague, where I'm also in right now. It's a sporting area in a park. You can see the running track, the football fields, trees, some streets. It looks natural to us and it looks pretty green. But if we go to the next image, it's the same image, but it's using infrared light as well. We can see a clear distinction between artificial grass fields used for the football fields and real natural grass. We wouldn't have been able to see this if we just used the visible spectrum. So the infrared spectrum is really useful for us to distinguish between different land cover types. If we go to the next slide, I want to highlight another major question I'm answering, which is regarding data resolution. Here you can see the first data source that I'm using, which is a Sentinel-2 image. These 10-meter resolution images are freely available from the European Space Agency. I recommend you check it out. And the second image that's just appearing on screen now is the one I'm comparing it with. It's a 0.3-meter resolution image from Pleiades Neo, a private satellite from Airbus. The difference between these data sets, a 10-meter resolution and a 0.3-meter resolution, is very significant for the accuracy of the analysis, especially in these dense urban areas. Looking out of my own window, if I look 10 meters in front of me, I already see a road, I see a tree, I see some shrubs, and I see another building. With only 0.3 meters, I only see the sidewalk. It's a very significant difference, and hopefully it will show very nice high-resolution results as well. I'm currently in the final stages of this research, and we hope to include my findings and improve our data understanding of the biocapacity component. And I couldn't have done this research without the knowledge and training I received through the IEFLL partnership. So thank you guys again. And I will hand over back to Eric, who will share now how to engage with the dataset.
We invite you to engage with the data in spreadsheet format. If that format works for you, you can access that through our website, as was noted before. We also syndicate our data through other platforms as well. A notable platform that a lot of you have probably used before is the data platform offered by Global Footprint Network, which is available at data.footprintnetwork.org. And so they'll be updating their platform with this new release of data shortly. Some of you might also be interested in some of the microdata associated with this, as we profiled at the start of this presentation. Let's say, for example, ecological footprint with the cropland component, that's the aggregation of hundreds of food types of crops and so on. And so we've got detail down to the individual crop type for oats and so on, for example, how much area was used, the yield, and so on. And that is available as well if you are a researcher that is working on research questions related to that micro data. So with this, we offer our thanks. Thanks for joining us on this webinar to introduce you to the 2025 edition of the National Ecological Footprint and Biocapacity accounts. Thanks to my co-presenters today, and to also our co-authors who did not present with us today, but have been joining us in celebrating the launch of this data and making use of it already in other additional applications that can leverage this data as well. Thanks for your interest to everyone who's joined on this webinar in this data set and on this topic. This international data set is used by many people and organizations around the world. On this webinar, we've had registrations from so many countries extending over many time zones. We also asked about organizational affiliations, and we had people signing in with affiliations including the United Nations, national governments, local governments, businesses, charitable organizations, not-for-profit organizations, research institutes, educators, and people who are personally interested in this, even if they might not be affiliated with an organization. So thanks so much for your interest. And we all thank the biocapacity of this planet, the biodiversity of this planet, and the ecosystems of this planet for providing so much to us as humans, and also for putting up with us and our pressures upon the lands and waters that sustain us. Today is Earth Day, and in whatever ways that you reflect and mark upon this day, we thank you for supporting our efforts to appreciate in detail the Earth's biocapacity and the demands we place upon this as measured by our ecological footprint.
Thank you so much for joining this launch of the new edition of the account. We really appreciate all your questions or your engagement. If you want to use our data, you can use the website that we have pasted in the chat. And also for more questions, I'll paste our email in the chat again. If you have more questions for us, you can always email us. This concludes our launch for today. Thank you so much.